Imagine holding in your hands a living legend, an animal thought lost to the Ice Age, now alive again. Meet Romulus, Remus, and Khaleesi, the world's first genetically resurrected dire wolf pups, brought to life by cutting-edge science and the ambition to reverse extinction. These pups are the result of groundbreaking work by Colossal Biosciences, who used ancient DNA, gene editing, and cloning to revive a species that vanished over 12,000 years ago. The dire wolf, Anasaendirus, once dominated North America, hunting massive prey like bison and horses with its powerful jaws and robust bill. Compared to today's gray wolves, dire wolves were larger, stockier, and had broader heads, thicker legs, and stronger teeth adaptations for bringing down big game and surviving in harsh Ice Age environments. But as the world marvels at these living legends, a debate is raging. Are these pups truly dire wolves? The fearsome predators that once roamed North America? Or are they something else, just ordinary wolves with a few extraordinary changes? Stick with me, because by the end of this video, you'll know the wild truth behind these creatures, and it's far stranger and more important than you think. And if you're fascinated by the blurred line between science fiction and science fact, hit that subscribe button, smash the like, and ring the bell. You're going to want to be here as the story unfolds. To understand how we got here, we need to go back. The legend of the dire wolf. 12,000 years ago, North America was the kingdom of giants. Towering ground sloths, massive mammoths, herds of wild horses thundering across endless plains. And among them, the dire wolf, Anasaendirus. Not just a bigger version of the modern gray wolf, something more ancient, more brutal, more perfectly adapted to the savage rhythms of the Ice Age. Standing nearly 40 inches at the shoulder and weighing up to 150 pounds, the dire wolf was built like a tank. Stocky, thick-boned, with jaws powerful enough to crush through bone and sinew. Its skull was broader, its teeth larger, its legs heavier compared to today's wolves. This wasn't just a sprinter, it was a bruiser, a pack hunter capable of dragging down mammoths, bison, and even young mastodons. Dire wolves weren't solitary monsters either. Fossil evidence from places like the Labra tar pits tells that they lived and died together, hunting, feasting, and sometimes, tragically, perishing side by side. But with the end of the Ice Age came disaster. As their massive prey disappeared and their climate shifted, the dire wolf, so perfectly tuned to an ancient world, could not adapt. Within a few thousand years, they were gone, extinct. Or so we thought. The dream that was cloning. For centuries, extinction was seen as final, death beyond recall. But then, in 1996, a sheep named Dolly changed everything. Using a technique called somatic cell nuclear transfer, SCNT for short, scientists at the Roslin Institute in Scotland pulled off the impossible. They cloned a mammal from an adult cell. Now, here's how they did it. They took an unfertilized egg cell and removed its nucleus, the part containing DNA. Then they inserted a nucleus from a somatic body cell, in Dolly's case, from a mammary gland. With a jolt of electricity, the hybrid cell began to divide and develop like a natural embryo. The embryo was implanted into a surrogate mother, and months later, Dolly was born. For the first time, the blueprint of life could be copied, not just in theory, but in living, breathing form. The implications were staggering. Cloning livestock, endangered species, even maybe extinct ones? But cloning isn't the only way to rewrite nature. Other variations like the Roslin and the Honolulu techniques refined the process further, sparking a new era in genetics and stem cell research. But even cloning had limits. You needed intact DNA. And after thousands of years, dire wolf DNA simply didn't survive well enough. And that's where an even more powerful tool enters the scene: CRISPR. The rise of CRISPR. In 2020, scientists Emmanuel Charpentier and Jennifer Doudna won the Nobel Prize in Chemistry for their work on CRISPR-Cas9, what some call the most significant scientific discovery of the century. CRISPR is like a pair of genetic scissors. It allows scientists to find a specific sequence in DNA and cut it, delete it, replace it, rewrite it. It started as a defense mechanism in bacteria, a way to remember and destroy invading viruses. But Charpentier and Doudna figured out how to repurpose it into a tool, one that could edit the DNA of any living thing. This discovery won them the Nobel Prize in 2020 and transformed medicine, agriculture, and now de-extinction. With CRISPR, Colossal Biosciences didn't need a perfect dire wolf genome. They could take gray wolves, their closest living relatives, and edit them to mimic dire wolf traits. Bigger size, stronger jaws, thicker coats. It wasn't true cloning, it was something entirely new. Enter Colossal Biosciences. In 2021, geneticist George Church and entrepreneur Ben Lamb founded Colossal Biosciences, a company with a jaw-dropping mission: to reverse extinction. Together, they dreamed not just of bringing back the woolly mammoth, but of creating a new conservation revolution. Launched in 2021 with $15 million in seed funding, Colossal exploded in growth, attracting investors like Tony Robbins and Thomas Tull. Today, they're valued at over $10 billion, working on reviving not just dire wolves, but mammoths, thylacines, and even the dodo. And their mission? To use de-extinction technology to restore ecosystems, combat climate change, and push the boundaries of life itself. But not everyone's cheering. With great power comes great controversy: the ethical storm. Bringing back an ancient predator isn't just about scientific prowess. It's about responsibility. And critics are raising hard questions: animal welfare. Cloning and gene editing often lead to high failure rates, miscarriages, deformities, painful deaths. Even Dolly the sheep developed health issues young. What sufferings do these resurrected animals endure, hidden behind the glamour of headlines? Conservation priorities. Should we be spending hundreds of millions to resurrect lost species when thousands of living ones teeter on the edge of extinction today? Would it be better to protect the endangered red wolf than to create ghostly white hybrids? Ecological reality. Even if we bring back dire wolves, where would they live? The Ice Age ecosystems they once ruled are gone. Their prey is gone. Releasing them would be impossible. These new wolves will likely live their lives in controlled sanctuaries, living museums of what once was. And most controversially, authenticity. Romulus, Remus, and Khaleesi are not true dire wolves. Colossal's dire wolves aren't pure Anasiondirus. They're hybrids, genetically modified gray wolves with about 20 key edits to mimic dire wolf traits. They may look the part, but they're not true dire wolves. Their DNA remains 99% gray wolf. Their behaviors, their instincts, their place in nature, all shaped by a modern world their ancestors never even knew. They are genetically modified gray wolves with some ancient traits stitched into their code. As paleontologist Dr. Julie Metchin says, a species isn't just its DNA, it's the world it lives in, the pressures it faces, and the prey it hunts, the life it leads. In other words, you can mimic the body, but the soul of the dire wolf, the true soul, might be forever out of reach. Where does this lead us? Science has given us the power to reach into the past and pull fragments of it into the present. But resurrection isn't perfect. It isn't simple, and it carries a cost. Romulus, Remus, and Khaleesi are not just experiments. They are a mirror, reflecting our awe, our ambition, and perhaps our hubris. So the question is no longer, can we bring species back? It's, should we? If you found this journey through ancient predators, futuristic science, and ethical dilemmas as mind-blowing as I did, make sure you subscribe for more deep dives into the wild edges of science and nature. Smash that like button, share this with someone who loves wolves or genetics, and ring the bell so you never miss a story like this. And if you thought resurrected direwolves were chilling, wait until you see the deep-sea creatures lurking in the darkest parts of our oceans. They'll make even the fiercest predator look tame. Click here to dive into a nightmare you won't forget.